Welcome to Longevity Industries' presentation of the Destiny of Manufacturing podcast. I'm your host, Dean Phillips, and I'd like to thank our sponsors today, the Precision Metal Forming Association and the PMA's Educational Foundation, for helping us put on this show. I have the distinct pleasure of having Dr. Steve Catt here today from the ARM Institute, where he is the Deputy Director of Education and Workforce Development. Welcome, Dr. Catt. How are you, sir?
Hi, Dean. It's so nice to be here. Thanks for asking.
It's great to have you. Tell us a little bit of the background of yourself and of the ARM Institute and what the ARM Institute stands for.
Oh, sure. Well, let's start with that. The ARM Institute is one of 14 institutes through the Manufacturing USA network, and it stands for Advanced Robotics for Manufacturing. And our intent is, the reason why we exist is to create the technologies and break down the barriers to allow manufacturers to integrate robotics at a much greater rate than is currently happening. And on the other hand, we need to have a skilled workforce to handle those new robots and those new aspects of automation. And that's the other aspect of that we try to portray. So again, ARM is the Advanced Robotics for Manufacturing, and I'll talk more about that in a little bit. But to give you a background about myself, I worked around 30 years at a community college. I was the executive director for workforce development and worked many, many years solving a lot of training problems for manufacturers through the Western Pennsylvania area, which provided a wide variety of metalworking and plastics and energy. Of course, in the last couple of years I was working there, energy became much greater because of the shale gas play that is in through Western Pennsylvania and the Upper Appalachians. And so we had to turn around and create a workforce that was ready for that as well. And that I was also the college's chief grant writer, which allowed me to do many creative things. One of the things I did was I helped create the associate's degree in robotic technology. And I worked closely with Carnegie Mellon University to derive that. And so whenever they were approaching the Department of Defense for a major grant, they were kind enough to ask me to participate in the writing of the proposal. And I found out what they were about and what they were planning for this new organization called the ARM Institute. And I said to myself, that is what I want to do when I grow up. So as soon as the opportunity became available, I applied, and this is an exciting job at this point, looking into the future and preparing the workforce for a bright future in the United States. So that's where we are right now, Dean.
Great. So let's elaborate a little bit about that, of where you think the future of manufacturing is going and what it's going to take to get there. What do you think is one of the greatest hurdles we have to overcome to achieve what we're going to need to have in 5 years? I know that's a very broad question and almost a challenging moving target, but
it really is.
What are some of those challenges?
Sure. I tell people that if I was not ADD before I took this job, I am now. You're right about it being a moving target. It is every day, every technology that we're involved in, and the workforce itself, and our society in general is changing at such an exponential rate that it's hard to put a finger on anything. But that's what we're trying to do. So you ask, what is the most challenging thing? I think especially in manufacturing, from a workforce standpoint, and knowing a little bit about your audience, Dean, I think the most challenging thing is to create an adaptive workforce. That is skilled labor that is willing to continuously learn and adapt itself to new technologies and learn new skills almost on a daily, monthly, yearly basis. And we have to get used to not being like our grandparents who had the privilege of having a job, learning it, and then pretty much their entire lifetimes, their jobs didn't change that much. I don't know about you, but my job changes pretty much every day, if not even less than that. Learning new software, learning new relationships, learning new how to arrange your work and adapt to it. The greatest thing we have to do is to create a workforce that can adapt. The region or the nation that figures that out first is going to be the most successful. It's all about the workforce at this point.
And that is a challenge, I think, as a whole to achieve that, because how do you train people to be adaptive? I think it's a very difficult thing, as most people are used to learning a skill like anything else, but to teach them to be able to adapt to change and instead just adapt the core principles of things, problem solving, and just understanding those aspects of manufacturing, and not have to just say, I am a mechanical engineer specifically in this industry, and instead being reactive to how the industry changes. I think that's a difficult thing for most people that are trying to learn a skill or a trade or even a technology. What are some of the things that you're doing to help them adapt to that?
Well, we're a new institute, Dean, so we've only been in operation for about a year and a half. So we have some nice strategic thinking, but we're just enacting some of our actions at this point. But one of the things that we're trying to do is to align curriculum across the United States in these new technologies to keep up with the evolution of the technologies. And so we're trying to create, one thing that's happening is that if you think of the silos that occur out there, either by industry, and then also region by region, there's not a whole lot of communication when you talk about training and skill development among it within the United States. And so one of the things we're trying to do is to convene experts and subject matter experts, educators, economic development people, and corporations and small manufacturers all in one space so that we can have a viable conversation about what they need to do, what they need, and what we need to do to accept those challenges. We've been convening these road mapping sessions for the last couple of years and learned so much. And then we're also hiring research agencies to assist us with that as well. One interesting tidbit that we have derived is that we worked with a group called the Boston Consulting Group, and they have estimated that there will be 900,000 new jobs created just in Industry 4.0 from those kind of new technologies. And these are jobs by the year 2025. And these are jobs that the job description has not been written for yet. And so one of the challenges we have is, how do you prepare a workforce for jobs that have not even been created as yet? And so one of the things we are talking to all of these subject matter experts and trying to get our hands around is the fact that we need foundational skills that we can all agree on, that everyone will need these foundational skills, and then they need to constantly build upon those skills as we evolve into these new technologies.
Right. And I think that that's a good approach, because most of the people out there that have been in manufacturing for a period of time have probably lost some of those skills due to I've worked in this industry for 25 years. They probably are not as flexible as somebody who's just starting out in a career and just got out of let's say a college, and in the time that they were in college, they took 10 different classes in multiple fields of study specific to their industry, engineering
Right.
or whatever. And so they probably are a little more flexible to that going in. Does the ARM Institute, do they focus on identifying future leaders?
That's a great question, Dean. At this point, we're doing a couple of things, and identifying those future leaders is I guess a secondary thing that we're doing, because we're finding really good people out there. But the main thing we're doing is identifying best practices and good programs and good training facilities across the nation. There are really good things happening throughout the United States, but they're relatively isolated. And so what we're trying to do is to expand upon those good curriculum, good programs that we think have the most potential, and scale them in appropriate ways and enhance them so that if something is really successful in Connecticut, for instance, can we transfer that same program or a similar program to Texas, where there's a gap in that particular skill level there? And so that's one of the things we're trying to do. You also, Dean, you also brought up a good point, too, that I don't want to lose, is that the students coming right out of college and right out of high school, as a matter of fact, they do have some really good skills in the fact that they can be adaptable and they're not afraid of technologies, those kind of things. But as far as the worker who's been in the place for 25 years, they are even more valuable. And I think one of the successful practices I've seen some manufacturers do is really use an effective mentor system where it's mutual mentorship in the fact that the older worker knows the culture, knows the processes, knows the ins and outs of how to actually produce that particular element. And they know that their organizational knowledge is just extremely valuable. While the new person coming in has the technological prowess many times and is not afraid to try those new things and that kind of stuff, but they both, in their respective ways, have gaps. And so if you could do mutual mentorship where the younger person can teach the older person about the technologies and help them adapt to those new technologies, whether it be a new handheld computer or a new PLC system that is being used and that kind of stuff, that's valuable. But the older person can also embed that organizational knowledge and the history and work ethic and all the good things we like about the existing workforce, and try to transfer that more effectively. And so, again, I've seen real success within manufacturers themselves with a mutual mentorship partnership whenever a new employee is onboarded.
Right. Tell us, specific to robotics, what are some of the challenges specific to robotics that perhaps some of the other fields aren't experiencing when it comes to workforce development? I would think that you're probably not challenged as much by finding interest from students. I think people think robots are cool and they're more willing to join that field than, let's say, I want to get into studying oils,
Mm-hmm. Yeah, I think that's an interesting question. Well, robots are a double-edged sword. We hear it both ways. Especially younger people are attracted to robotics, and it is an attractor to the whole industry and manufacturing processes. If you say robotics, that's pretty attractive to younger people. To other generations, robots are known to take jobs. At least that's what the rumor is out there. But I've had the privilege of touring a lot of companies, both large and small, who have embedded robots into their processes. And I ask the same question every time I go into of their supervisors and their managers and their HR directors. I ask this question. I said, well, I see this new robot here. How many people did you lay off, or how many people did you let go because you automated? How much money did you save on that? And they all look at me, every one of them, 100% have looked at me kind of cockeyed and said, we haven't let anybody go. We would never let anybody go from our plant because skilled labor is really valuable and they know our system. So everyone is either redeployed or they're upskilled to take care of the robot in the process that they know so well. So I have never heard anybody lose a job because of an automated system coming in. Now, what I have heard is that especially for small manufacturers, there have been stories of a very expensive robotic arm sitting in a corner of the plant collecting dust. And it's because at one time, an installer put it in, and it was real effective for its period of time, but after 4 months, 6 months, a year, either the product changed or there was something that went wrong, and there was no one there to reprogram it or who knew how to troubleshoot. And so what I'm encouraging manufacturers to do is to take an existing employee, get them trained in automation, mechatronics, something that's appropriate in that area to get them up to another level, to get them exposed to robotics in some way. And that person then becomes extremely valuable because they know your system, they know your processes, and they can translate what needs to happen with that robotic arm or with that robot and be able to program it accordingly. From what I've witnessed so far, that is the most effective way that especially small manufacturers have to integrate automation into their processes.
And I'm sure that that's something that is a difficulty, especially for small companies, to have the technology expertise in-house to be able to troubleshoot, be able to reprogram, because as you mentioned, we programmed that when it started. Then when it came to doing it again, they hadn't worked on it in a year. Right.
And it's one thing for large corporations like Ford and the large automotive and large aerospace and those kind of things. They have whole universities or training programs among themselves, and they have the resources to be able to handle that internally. But when you go down the supply chain and you look at the small manufacturers, they don't have that luxury. And so one of the things we've identified that as a major problem. And so we like to do project calls. That's how we distribute the monies that have been granted to us through the Department of Defense. And our first project call, Dean, was to develop apprenticeship programs for small, medium-sized manufacturers, specifically in robotics and automation. And we purposely kept that relatively ambiguous so that people could be as creative as they could be in solving that particular problem. And we have 6 projects that are funded at this point. They're just beginning and show great promise, so that if all 6 of them work out, or if any one of those 6 works out, what our expectation is to take that program, that training program, and start scaling that up nationwide so that it start solving that problem for small manufacturers.
That's great. I mean, I think that's just outstanding to be able to contribute back in that way. I think that really helps the bigger picture when you can help some of these smaller manufacturers to develop those skill sets. As you mentioned, it's far easier for a large manufacturer who has, 500 robots in their facility, and they're working on these every day and programming them and reprogramming them such that they know them like the back of their hand. But getting a skilled force that actually can work on it, that's a challenge. And but that's great that you guys are addressing that. And I think as part of workforce goes, that's an important area. What other changes do you see coming down the road here over the next 5 years that are going to really impact how we look at workforce, specific to robotics or not?
Sure. Well, one of the things that impressed me was, I have learning moments almost every day. I was touring a company, and they had two mechanical engineers where all they did was look at a process in their company and figure out a way to roboticize it or automate it. And the first project was kind of cool. It was just taking a robotic arm and taking a piece of raw material, placing it on a CNC machine, waiting, and the CNC machine would do its thing. It would then take that part and stack it in the finished product. And so that meant that a person did not have to physically take a raw material, put it on CNC, and then place it someplace else. That robotic arm did that. But so their full-time job, and that was the first project they did, and then they get more and more sophisticated. But what really impressed me was that they've been getting into a robotic arm, and the arm has tools at the end of it that are pretty standard. And some of those tools just weren't working for what they wanted to accomplish. So they 3D printed a special tool at the end of the arm to be able to do the project that they wanted to do. And so they've been doing the combination of automation, robotics, and 3D printing to make that process work. And it kind of blew my mind a little bit because then I understood what Industry 4.0 and advanced manufacturing is really all about, is that it's not the fact that individual technologies are evolving and getting better and better, but it's the combination and the collaborative nature of those technologies starting to converge with big data, cybersecurity, robotics, 3D printing, additive manufacturing, all of those starting to converge. And we're seeing possibilities happen. So in the next 5 years, if you ask me what we need people who have the basic skill level as far as understanding basic engineering, chemistry, mathematics, across the board. We need a foundation for that. But more than ever, especially in the United States, we need to enhance that creativity. And to look for those unique solutions that happen on a shop floor every single day, but now with these advanced technologies, how to apply them and how to converge them and collaborate them in ways that make it even exponentially more efficient to do these processes and in a safe way.
Yeah, that's one of the areas I kind of had overlooked when STEM had kind of moved into the STEAM aspect and adding the arts to it, was what the arts brought to it as a level of creativity. And these students are amazing because they don't necessarily know the limitations of what they can build when they're going in and designing some of these things. And what they can come up with is just amazing to me. When you watch some of these students, it just blows your mind to see the solutions they can come up with. Because they just don't see the limitations that certain people already have because they've been manufacturing a certain way, all they can see is, well, I can't build this because I never have been able to in the past. Tell me.
Right.
Sorry, go ahead.
Oh, that's good. Thank you.
Do you, speaking on that extent there, where you're talking about adding that aspect to it, what do you see as the opportunities for the collaborative robots, especially with the new smart manufacturing kind of taking hold and people becoming more familiar and working around robots? And in that aspect, do you see more and more of these opportunities taking place?
Very much so. There's a great project that we are involved in where they have a lot of problem and a lot of injuries because when they produce cars, under the undercarriage of the car is raised up, and they have to screw in undercarriages to the bottom of the car. And of course, you can imagine trying to hold that heavy metal up and find the screws and screw that in at the same time is a difficult task. And so for people to do it, it's usually, they can only do that, they have that in 25-minute chunks because your shoulders just can't handle it no matter how strong you are. And then there's a lot of injuries, long-term injuries because of that. So they're trying to find a collaborative robot. They're developing it right now where the robot will lift that heavy metal object up and position it, and then the human comes in and fine-tunes that positioning and then screws the appropriate rivets and screws on. And they don't have to hold it up at the same time. So they're working in the same workspace. The robot arm who is doing the work has to be extremely sensitive to the human that they are working with. And that's just one example of doing a dull, dangerous, dirty job that a robot can do, and a human can come in and fine-tune it and do it exactly the way it should be, and so that partnership exists. We're going to see more and more of that. I've heard roboticists say that what they want to do is to evolve the cages, the safety cages, out of manufacturing so that robots are so safe because of their sensor systems and their intelligence that the human does not have to worry about being injured whatsoever working alongside a robot. We aren't there yet, but that's one of the things I think in the next 5 years you're going to see vast acceleration toward.
Yeah, I look forward to that day because there's been some injuries around robotics, mainly just you got to have a level of respect for it, just like you do any piece of equipment. And
oh yeah, absolutely.
Sometime that we, as humans, a lot of times we'll do things that go beyond comprehension. You know, all of us stand on a chair to change a light bulb that we shouldn't. You're on a ladder trying to cut a limb off a tree, you know, and you're going into areas that you know not to be safe, but just going in there for a second. Well,
sure.
You know,
and it's a combination of training, awareness, and the technology to handle that as well. I mean, it's both the responsibility of the technology that we're working with, but it's also the responsibility of the human.
Right.
So we have to share that responsibility when we work together.
Great. Dr. Catt, I am afraid we are out of time today. I really appreciate it. Thank you so much for being here on the show. Your insights have been great, and I look forward to speaking to you again. This has been the Destiny of Manufacturing podcast. We'd like to thank our sponsors, the Precision Metal Forming Association and the PMA's Educational Foundation. Go out there and make it a great day.